Hello, this is Ross Reichart from MBS, and today we'll be talking about an introduction to web services. We'll cover three areas today. Firstly, what are they? What are web services? How do they get used? And then some samples. Today is just an introduction for people who might have heard the term but aren't really familiar with what a web service is or why they'd want to use one. The concepts I'll cover in this presentation will be quite general but can be expanded on in later presentations. In those later presentations, we can look at technical differences between different types of web services, and we can also look at the implementation of web services on some multi-value databases. Our focus in those later presentations will become more on multi-value databases, but today the general concepts we'll be covering will be applicable to multi-value databases or the SQL relational type databases. Firstly, what are they? What are web services? Well, let's start with a definition. And according to the World Wide Web Consortium, a web service is a software system designed to support interoperable machine-to-machine interaction over a network. It has an interface described in a machine processable format, specifically WSDL. Other systems interact with the web service in a manner prescribed by its description using SOAP messages typically conveyed using HTTP with an XML serialization in conjunction with other web-related standards. Well, wow, that's quite a mouthful and quite complex, so let's break it down. But before we do, a bit of a detour. Firstly, who are the W3C? Well, the W3C, or the World Wide Web Consortium, to give them their full name, is an international community where member organisations, full-time staff and the public work together to develop web standards. The W3C shepherds web standards through, they're the body that agree on web standards, publish web standards, covering all sorts of web technologies such as HTML, cascading style sheets, XML, web service standards, SOAP, and so on. Many standards that are used across a whole range of web technologies. The result of that is that now vendors can come together with different products and have a high degree of confidence that their products will work with other people's products if they adhere to these standards. And it's got the great benefit of opening up the web for a great deal more functionality because of that interoperability that standards have brought. The other thing to note on the definition that we covered on the previous page is that definition referred explicitly to SOAP and XML. These days, as we'll see, web services don't necessarily need to use either SOAP or XML, but they can do. We'll cover a bit about that a bit later in the presentation. But firstly, let's go back to our definition. So here it is again. A web service is a software system designed to support interoperable machine-to-machine interaction over a network. It has an interface described in a machine processable format, specifically WSDL. Other systems interact with the web service in a manner prescribed by its description using SOAP messages typically conveyed using HTTP with an XML serialization in conjunction with other web-related standards. So it is quite complex, but we'll break it down into four major points. The first one being that this definition refers to a machine-to-machine interaction over a network. And that's an important point to remember. Web services are about providing data from one machine to another machine. This isn't about providing data for humans to consume. It's for machine-to-machine interactions. So the web services provide a common method for different systems to exchange data. They are also sometimes known as Application Programming Interface or an API, or sometimes a Web API. And they are very commonly used these days for web and mobile applications. So if you have a mobile phone and you get online and use a mobile phone app that updates data for you, then almost certainly they are using some form of web service, and very likely the sorts of web services that we'll be talking about today. The second point in the definition is it says the interface is described in a machine processable format, WSDL being web services definition language. The web services using WSDL advertise their capability, and this is necessary for interaction. So let's assume that you have an application and you want to expose some functionality of that application to other people via the web, via the internet. So you write a web service and publish it. Well, those other people that may want to take advantage of your web service need to know how to use it. They need to know what method call, they need to know what data they need to provide to the web service, and they need to know what data the web service is likely to provide back to them. All that is done by the WSDL, the Web Services Definition Language. It will describe all those interactions. WSDL itself is an XML-based language, and it's very well used by tool sets such as Microsoft Visual Studio. You can read WSDL and very simply set up some infrastructure inside an application to use a web service. So that's the job of WSDL. It describes the interface, and it's necessary for foreign systems to understand the capability of a web service. And as I said, WSDL itself is an XML-based language. Thirdly, the definition said SOAP-based messages are typically conveyed using HTTP with an XML serialization. So when web services were first introduced, they were what were known as SOAP web services, and they transmitted their data in XML format using HTTP. Nowadays we also have RESTful web services which use JSON. So SOAP is a web standard based on XML. SOAP is a standard that is overseen by the W3C, as I said, based on XML, and it transmits data only in XML and not JSON. We'll get into that a bit later on. These days, in addition to SOAP-based web services, we also have RESTful web services, and we'll cover the two in a bit more detail a bit later on. And lastly, the definition says the web services are used in conjunction with other web-related standards. The major ones of those are HTTP and HTTPS. HTTP is Hypertext Transfer Protocol, and that is the protocol that is responsible for requesting and receiving information across the web. So when you start up your browser and you go to request a web page, your browser will compose what's known as an HTTP GET request, and that will ask the remote website via the remote website server for a particular page. That remote web server will then bundle up that page in HTML format and send it back to you using HTTP. Your web browser then receives that HTML via HTTP and turns that into a web page it's displayed on your screen that you can use. So that's the job of HTTP. HTTPS extends that by providing some encryption of that data. As the data transfers across the internet, it can be encrypted via HTTPS, which prevents snooping by unwanted parties. So that breaks the definition down into its major parts. But put simply, a web service is a resource allowing a computer and a server to exchange data using ubiquitous web technologies centered around Hypertext Transfer Protocol, or HTTP. When a web service is requested, the web server will supply data, usually in XML or JSON format. But more about formats later on. The thing to remember at this point is that there are many already existing technologies that are being used by web services. Things such as web service software like Apache, Tomcat, IIS, or Jetty. Web protocols such as HTTP or HTTPS. HTTPS itself bundles up other technologies, encryption technologies like SSL or TLS. So these products are all being used to support and service web services. These technologies weren't specifically developed for web services, but they are being used for web services. There's a great advantage to this for web services. The advantages of using ubiquitous technologies are that those technologies are well understood. Things like HTTP, web services, XML, networking technologies, existing infrastructures, routers, hubs, switches, web servers, firewalls, all these things are existing technologies that are already in place. They're well understood. They have great known tool sets for development and debugging these technologies. There are plenty of people around who know them well and can set them up and administer them. So these ubiquitous technologies are very mature and very well understood. So web services themselves, by leveraging off these technologies, can provide a great deal of extra functionality to our web usage without the burden of an equal great number of new technologies to understand and learn. A lot of the technologies that web services currently use are already in use and are already understood and were developed before the concept of web services were developed. And now on to data formats. We've talked briefly about data formats. But there are two major data formats, XML and JSON. But firstly, what's a data format? Well, a data format is a way of bundling up some data. Remember we said that web services are primarily designed for the transfer of data from one machine to another machine. So those two machines at each end need to know how to read the data. When they get some information from the other machine, they need to know how to read it and get the data out of that, or put the data in it that the other machine will require. So that's the job of data formats. It's to format the data in a particular way so that the two machines can understand it. And there are two major formats. There's XML and there's JSON. XML is the extensible markup language, and JSON is a bit newer than XML. It's the JavaScript object notation. Firstly, XML. XML is a standard published by the W3C as part of their standards body. XML is a subset of the SGML language, as is HTML. So in fact, XML and HTML are relatives of each other. And if you ever see a block of HTML and you put it beside a block of HTML, you'll understand that they are in fact relative to each other. You'll see that there are a number of similarities in the layout of the two languages. There are a lot of differences too, but they are similar in their structure, their layout, and that's because they are in fact relatives of each other. It's a major difference though. HTML describes a page layout. It's a presentational language, whereas XML describes the data. XML is really used for interoperability, for transferring data. So HTML describes the presentation of a page and is therefore intended for direct human consumption. XML is intended for transmitting data in a specific format from one machine to another and is therefore used for machine consumption and not direct human consumption. Here's a sample of some XML. This is a very, very simple sample, and as you can see, it describes one contact being me. It's got some my first name, my email, a couple of phone numbers, a mobile and a landline number, and the company that I work for. So it should be fairly simple to understand what that block of XML is doing and how it's describing it. And if you want to modify it to put in a different phone number, for example, it should be fairly obvious what needed to be done to do that. That's an extremely simple sample of XML, and XML can be much more complex than that and describe data much more in much more complex manners than that. You can see from that simple example though that the actual tags, if you like, the infrastructure of the XML, the tags that say what each piece of data is, form a significant amount of the overall data that would be sent across the internet. So in that sense, while XML is very, very flexible and you can send complex amounts of data or complex structures of data, it's not very efficient because the tags do take up quite a lot of the actual data being transmitted. Now to JSON. There is no real standard to JSON, but you can find a specification at www.json.org. So there's no actual standards body overseeing the future development of JSON, but json.org will show you the specification. It's a very simple specification. It's very easy to read for both a human and a machine. It's much less verbose than XML, but it's not as descriptive as XML. So we can do a lot more with XML than we can with JSON. But JSON serves our web services purpose very nicely indeed. And as we'll see in just a moment, let's have a look at an example of JSON. We can see the same data there, the contact being myself again. The same sort of data is being transmitted via JSON, but there are no long verbose tags. There's some curly braces and some square brackets, but there are no actual tags. So while it's less descriptive, you can't structure data in as complex a manner, it's more efficient. The tags don't take up nearly as much space as they do with XML, and that's one of the advantages of JSON. Okay, RESTful web services. There are two types of web services, RESTful web services and SOAP web services, and we'll talk about RESTful first. REST stands for Representational State Transfer. And systems which follow REST principles are known as RESTful systems. REST itself is not a standardized protocol. There's no standard behind REST. It's really just an architecture describing how a system would work. REST itself was first described by Dr. Roy Fielding in his PhD, his doctoral dissertation in 2000. And Roy Fielding went on to become one of the chief architects behind HTTP, the Hypertext Transfer Protocol. So Roy Fielding himself is very heavily involved in the engineering of these protocols, these technologies that we use on the web. And he was the first one that described this concept of representational state transfer or RESTful architecture. RESTful web services only use HTTP or HTTPS for service interaction. They're very closely tied in with HTTP and HTTPS. But they can use either JSON or XML to transfer data. Typically they'd use JSON, but they can use XML as well. So the RESTful web services, as we said, are very closely tied in with HTTP. HTTP has 4 major methods. There are other methods, but we'll only cover 4 major ones, being get, post, put, and delete. And these 4 methods, in order, allow you to request some information from a resource, allow you to create some information on that resource. So you had a contacts database as your web service. A post request would allow you to add a new contact into your database. The put method allows you to modify an existing resource, so you could use put to edit some piece of information about some of your contacts, and delete allows you to remove a resource. RESTful web services also are tied in with the security features of HTTP, the authentication and authorization of HTTP, to allow some control over who has access to your web services. They also support SSL for encryption of the data as it's transferred across the internet. So RESTful web services are quite closely tied in with HTTP, and as we mentioned earlier, can only use HTTP. On the other hand, we have SOAP web services. SOAP itself is an acronym standing for Simple Object Access Protocol. It's a standard, again, overseen by the World Wide Web Consortium, and is usually but not always bound to HTTP. The SOAP web service protocol hinges around what are known as SOAP packets, which are bits of XML that describe what the web service is to do. Because we have a separate SOAP packet to do that, we don't have to bind it to HTTP methods as we do with RESTful. So it can use other protocols such as SMTP, which is the mail protocol. So it is possible to set up a web service that is transferred across email protocols and not HTTP at all. However, it's much more common to find SOAP being transmitted across HTTP. SOAP also only uses XML to transfer data, whereas RESTful web services can use XML or JSON. SOAP can only use XML. But how do web services get used? Well, there are a number of use cases for web services. The most simple would be a browser, using a browser. Browsers are fantastic at interacting with HTTP. That is, after all, what they were designed to do. HTTP being the language of the web, browsers, or the transport language of the web, browsers are terrific at using HTTP to request and receive information across the web. Not a really good use case though. As we said earlier, web services are designed primarily to transmit data from one machine to another. So if you used a browser to request a web service, and we'll see this shortly, what you'll find on the browser after you've requested the web service is a block of data in either XML or JSON format. Bit verbose, not very interesting, really not that useful for a human. So a browser, while it can be used, is not really a useful case. What would you use it for? After that, we have XL. XL has the capability to request data from a web-based source, a web service. So you can get XL to request some data from a web service and then lay that data out in a spreadsheet. And then from there, you can start to filter or do calculations or whatever that you can normally do in Excel. So that could be a very basic, simple reporting feature that could be set up in Excel, requesting real-time data from a web service. We can write something like a Windows application, and Visual Studio works well here. Visual Studio has the ability to read the WSDL of a web service and build some infrastructure inside your application that allows you to easily call the web service to either get or or create information on your web service. And doing that, you can create a Windows application that uses the data supplied by the web service. And we'll have a look at that in a second as well. Probably by far, though, the greatest use is web applications and mobile applications. So web application can be an application that runs anything from a desktop browser down to a mobile phone or a tablet. They run in the browser on those devices, and the data that drives those applications is supplied via web services. Similarly, the native applications that you download from the iOS store or the Android store, those native applications, when they need data from the web, and most of them do, will use some form of web service, probably either the RESTful or the SOAP-based web services that we've been talking about today. So a number of samples. So let's have a look at some. Firstly, the browser. If I can fire up my browser here, I have over here. We'll firstly look at a bit of WSDL. So here's a block of WSDL coming off a web service I've got set up on my machine here. So you can see this is what a big block of XML looks like. It's quite complex. It's intended for machine consumption and not human consumption. Let's look at some more interesting data. We've got some data on some aircraft movements around Australia. So we can see here, we can see a list of cities, dates, values for aircraft movements, and so on. Again, this is in XML, and as I said before, while you can use a browser to look at this data, it's not the most useful use of a web service. Let's look at Excel now. So here we've got an Excel spreadsheet. We want to look at some data here. So we go to data, we go to from web. I need to look up my my URL. Just hang on a moment. I'll get my URL from over here. Put my URL in here. You go, and that should get Excel to go and talk to the web service which is running on my computer. And here we can see a preview of the data. I say, yes, that's the data I want. Let's import that data. Excel will now go again and talk to the web service. Downloading the data. Bit of a warning message, which we don't need to worry about at the moment. Now, where do we want to put it? I'll put it in the top left cell. Click OK, and there's our data. Now that we've got it in there, we can choose to look at data for, well, it's just 1985 because that's what my query specified, but let's look at different cities. So we might want to look at just the data for Canberra, for example, and then we filter it, standard Excel stuff. And from that, we can then do graphs or calculations or whatever. As I've done that, Excel has built a query inside of that spreadsheet, so I can open that spreadsheet later on, rerun the query, and update the data in real time using the web service. So that's quite a useful use case for basic reporting use. We have a Windows application. I've got a sample here. Same sort of data. We're using the aircraft data here. Let's go full screen on that. And if I go up here and I put in a year, let's go 1985. We'll request passenger data. If I do the get data, it will go to that same web service and pull the data back and display it on my screen. And there we go. So that's the data from the same web service. This web service is running on a multi-value database on my laptop. It's all running locally. So there's the data for passenger movements. I can choose aircraft movements, get data again, and we can see the figures updating for aircraft movements. I can go in and choose a different year. So let's try aircraft movements for the year 2000, and there's the aircraft movements for the year 2000. I wasn't looking at closely, but I imagine that showed somewhat increase in aircraft movements between 1985 and the year 2000. But that's an example of a Windows-based application requesting data from a web service to update the application. Lastly, let's have a quick look at a web application. So here we have a web application. This again is running on a web server on my local computer. This has called up a list of customers. If I click my custom list here, there'll be a short delay while the application sort of refreshes itself and gets itself going again. A longer delay than I would have liked. Okay, it's taken my application a time to refresh, but there we've got customer information. If I click on one of these customers now, we can see the details of the customer. We can go back to the list, we can choose another customer. Now every time I click on one of these customers, it's actually making a web service request back to the web server, getting the data from the web service and repopulating the screen. It's not redrawing the entire screen. It's just redrawing the little bit in the middle when it gets a new piece of data. So that's quite quick. You can see that we can also go, and let's go into customer one, and customer one should have a .com.au on their email address. So we can choose to edit the customer. We can go in here and put a .au on the end, choose to update the customer. Go back to the list. Now if we go into customer one now, we can see that we've got the .au on the end of the email address. So that again was done by an update, or in our case a put request, because this is a RESTful web service. It's done a put request to update the data on my database, and it has actually updated that email data on my database. So that's a very common use of web services to provide that sort of functionality on a web application. So there's some basic uses of web services. That's all I have for today. So we just talked about a bit of an introduction to web services, what they are. We've talked a bit about the definition of what they are, how they describe themselves, how they run on ubiquitous technologies, how they're used for machine-to-machine interaction. We've talked about the data formats between XML and JSON, and we talked about RESTful web services and SOAP-based web services, and we lastly had a look at some sample usages of web services. So I hope that's been a useful introduction to you on what web services are and how you'd use them. My name's Ross Reichardt. I'm from MBS. My email address is there. If you've got some further questions, please send me an email. I'd love to have an email conversation with you. I'd love to see greater use of these web services on our multi-daily databases. And thanks very much for listening.